Okay, so if you have clicked this video, that means you want to know how the physics system in Fortnite. I said Fortnite. Damn it. This is supposed to be school appropriate. I mean, darn it. Okay. We're not. This is going to be hilarious. Oh, wait. Okay, we're recording. So, the physics system in Unity. So, there's key components to your 3D object with physics that you need to add if you want it to be lifelike. So, our first is going to be the sphere collider, or whatever sort of collider you're going to use for your 3D object. Say you're going to use a cube. Add a cube. Add object, please. Madame? Madame?
I'm good.
Okay, so we had this little midget cube, right? And as you can see, it has its his box collider on, which means that it can collide with other objects. But right now, this box does not have any physics except for the fact that it can collide with something. So even if we press play, which we do right now, okay, our box is going to do nothing. Wait, hold on. Wait, we need to move the camera so we can see the whole view. Now go to the main camera. Play. Maybe. Okay. Now, that's good. Okay.
This is a bad box.
Okay. Press play again. So, our box doesn't have any physics except for box collider. As you can see, everything has its normal physics. It can fall, it can collide, it can bounce. That sphere is normal, right? Our box is just a weird gravitating box. And if we want our box to be more lifelike, we would have to add some more physics to it. And one of those physics that we have to add to our box is our rigid body. So, when you get your rigid body, you'll see that there's gravity, there's cinematic, and drag forces that you could add to your block. And for rigid body, you'd only really want to add gravity unless you'd want to have a force that's always on it. So for now, we'll add, let's make this cube fat or heavy. Look how much it weighs. It weighs as much as Ian. Fatty.
Discrimination, I'm calling it.
Man, that was loud. Okay, let's do 500, because our cube is a bodybuilder, for crying out loud. So, as you can see, our box now has some forces. But, as you saw it there, our box has a greater mass. And when press play, you'll see that the box falls a lot faster than the sphere. That's because we made the mass a lot higher.
And
Which,
the head is hitting the cube.
yes. See, it just fell at the speed of light.
You mean at the speed of boxes?
Yeah. What you said. Or she. Whatever.
I'm not she.
Okay. So let's show our audience some more forces that we know about our 3D objects. So, Ian, can you give our box a constant force, please? So, right now as Ian puts a constant force on, a constant force is a force that is always on the box. Say we gave the force on the y-axis, negative 500. And as you can see, that green arrow here at the top, that is the y-axis. So our box, the y-axis, is the green arrow. So if Ian makes it go negative 500, that box will go negative 500 on the y-axis, which means plus 500 is going up and negative is going downwards, or we could add some bounciness to our cube. So let's go to our cube, and we get bounciness. And Ian, tell us how we get that new physics.
Well, we get that physics by going to assets.
To your assets log, and you make a new asset by creating a new
I think it's
physics material. Once you go to your physics material, then you'll see that you could add bounciness, which go up to the bounciness, and friction combine. So let's add the bounciness to our cube of, we want to add bounciness, not bounce combine.
okay. How much?
Just keep it at average. Put bounciness, okay? No, put your bounciness, okay? Put that at 500, because we want our
It
cube
only goes to 1.
to really bounce. Wait, it does?
Yeah.
No! Wait, hold on. Let's see this.
It only goes to 1.
Okay, so our bounciness only goes to 1. That's something to know for next time. So
You gotta name your things.
you always gonna name your assets so you can keep track of them. So, no, go
How the
back
heck
there.
do it?
Right click,
And
rename. So if you want to rename, you press the rename button and you could type in anything you want.
I was gonna type that. I wanna type
Bounce bum. No. Let's do
bounce box.
bounce box. It's revolutionary. Bouncy box. Saucy. Oh, wait. Okay. So now that we have our bounce box, we're going to take our bounce box and add it, the bounce box asset, and we're going to add it to our cube. So you're going to take your box or your asset and drag it into your box collider. That'll add the bounciness force to your box. So now if we press play, you'll see that our box is now a bouncy box. Not weird at all that it bounced. Wait, hold up. We only saw the shadow. So what we could do to see it is adjust our camera so that we could then see the box in the full form. And our camera view is at the bottom right of the screen, and you can see where the camera is as Ian moves it. Okay, so now we're going to press play with our camera in a new position. And as you can see, the box comes out and it bounced unusually. That's because it has the bouncy box physics that we added to it. So say we wanted, yes, we can improve it so that the bounce of the box is multiple. It would make the box,
Putting it maximum.
yes, okay. So we add that back to it just so that it reloads. And when we see our box bounce, as you will see in a moment, it'll bounce at a larger scale, and it'll bounce a lot more times because we increase the bounciness. Okay, let's get back to our box and let's add something to it.
Bouncing really high.
Yes, we'll never get it back. So let's not make that bounce so high. Actually, let's keep it at that. So let's get back to our constant force. If we wanted a constant force to make our box going forward, we could check the axes, which is our z-axis, and we can make it go however much we want. And one of the ways that you can make it go further is you could take it, slide, you could put your cursor on it, and drag
And I'm supposed to drag the Z.
the Z as far as you want, and it'll go on the other side if it gets to the border.
Just tagging my shirt.
And as you do that, it'll go up and increase. So say we leave our force at 81.41. That'll make the constant force for that box in that direction 81.41 in the z-axis. So if we did negative 81.41, it would go backwards. And if we did positive 81.41, it'll go forward. So let's see a motion capture of our box going forward. Please, Ian. So our box, oh no, it's bouncing away. Okay, so you can't really notice it there. But
Oh yeah, you can. It's
yes,
on its.
it's moving. But if we increase that to 500 or 604, then we can really notice how our box will go forward. On the road again. See, it just hit our figure. And now it fell out the world because it fell off our plane. Well, that's it for now. Thank you for watching the Physics in Unity for your 3D objects. Bye. 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 Bye.
Press the button.
Wait, why isn't it working? Oh my god! How do you stop?